The second part of our looking at inequalities here. This one should finally be a nice short video for us. Been too many long videos. So just a couple things to look at here. Let's say we've got a function, and let's say we want to know when it's 0, positive, or negative. We like the fact that it's nice and factored for us here. For finding when it's equal to 0, those exponents don't really matter. Zero product property, we can just look at each part, and if something to the 7th is 0, then that something has to be 0. So we just want x plus 4 to equal 0. We've just got x equals -4 here, and then x equals 3 there. So nice and simple there. So really what the goal of this, the point of this, is to look at this positive and negative part. So it's really funny what happens is we're going to give you on your test, for like the first few tests, we're going to give you a bunch of problems like this with inequalities next to them. We'll give you a polynomial and, less than 0, less than or equal to 0, greater than 0, all that. You'll solve those over and over and again. You'll be good to go. And then all of a sudden, after a few tests, we're going to throw something like this on there for you. We're going to say, when is this positive, or when is this negative? And it's amazing how it's going to throw some of you guys for a loop, when really it's the exact same thing. Positive just means greater than 0, and negative just means less than 0. So we just want you to solve x plus 4 to the 7th times x minus 3 squared greater than 0. It's really nothing different. It's nothing special. I don't know why it throws some people. One thing to keep in mind is that it is a strict inequality. 0 is not positive or negative. So positive is just greater than 0, a strict inequality. But otherwise, it's just the problems exactly like we did in the previous lesson. Just because we're using the word instead of the symbolic notation, it's the same exact thing. So what we found back here is what we needed. Those are called the critical points. So we'll put them on the number line. -4, 3, and then we'll test the intervals. Just the same as what we did with all those other problems. And so we'd have negative. This one's going to be positive because it's an even exponent. The odd exponent doesn't affect the negative or positive. Even exponents mean that can never be negative. So negative times positive, negative, and then positive, positive, that's positive, and then positive, positive, positive. Oh, and I forgot to put my open circles here because it is that strict inequality. And so if we want positive, we want this section here, and this section here. And again, because it's a strict inequality, I can't smush them together. I got to leave those separate. So I've got to say for this one, -4 to 3, and then 3 to infinity. And then for negative, I just want that section there, negative infinity to -4. So really nothing new here. Just it's the word instead of the symbol. Just don't let that throw you. Make sure you know that positive means greater than 0, and it's the exact same process, exact same thing. All right. So now we'll take a look at this next one here. And notice there's going to be an extra little note for us to fill in here. We're looking at our critical points. So far, we've only been setting it equal to 0, finding the solution. There's actually going to be one other spot. So first, let's do the normal part. Let's try to find when it equals 0. So make sure that you know this here. If you have a fraction and you want the fraction to equal 0, that means the numerator has to equal 0. And so my critical point here, when it's equal to 0, trying to find the critical point, I want x plus 2 to equal 0. So I want x equals -2. But it turns out that's not the only critical point. So what we talked about in the previous lesson is that to go from greater than something to going to less than something, to switch between there, it has to equal the number in the middle. So normally to go from positive to negative, you have to equal 0 in the middle. Well, it turns out that's not always quite true. So picture a function here. Let's say it's positive, positive. Let's say it keeps going more and more positive, more and more positive. It's actually possible that it can just jump. It can jump and then be negative down there. You might have seen this a little bit in Algebra 2. It's called an asymptote. And so it's possible for functions to jump. It's actually even possible you could have a function that even just has a little hole and it switches from negative to positive. So there's one other thing that you have to look for. In addition to solving the equation, you have to look for when things are undefined. Both of these scenarios have the same thing. The place where it switched from positive to negative is an undefined spot, a place where we don't have a point. There's no point on the graph at this. It just kind of randomly jumps. There's a gap in the graph. And so that's how it's able to switch from positive to negative without ever equaling 0. So we also have to look for when is this fraction going to be undefined? And of course, that's when the denominator is 0. So let's take a look at what our undefined critical points are going to be. That's going to be when x squared minus 9 equals 0. So when x squared equals 9, when x equals plus or minus 3. So it's two different things you have to look for now, both solving the equation, which here would be putting that equals 0, and where it's undefined, where there's any gaps in the graph. So for these rational functions, for these fractional functions here, really what it amounts to at the end of the day is just take the numerator, set it equal to 0, take the denominator, set it equal to 0. Okay. All right, so we'll put those on the number line. We'll have -3, -2, and then +3. All right, now take a look here. I'm going to have to try to do something like -2.5, -2.5 when I test this. Remember what we talked about in the previous lesson. When you are testing these, what you want is you want to have a factored form to test. So I'm going to take a look at this. I'm going to factor this. I'm going to say x plus 2 over x plus 3, x minus 3. Less than or equal to 0. I'm going to use that for testing here. I don't want to try to take -2.5 and square it. That would be annoying. All right, because then if I use this factored form, remember less than 0, I'm just looking positive or negative. And so I'll have negative the numerator and then negative, negative there. So that's going to be negative over positive, negative over positive. The whole thing is negative. And then here's what I was talking about. All right, I got to test -2.5. Well, if I just need to know if things are negative or positive, that's okay. -2.5 and 2 got more negative than positive. So I'm going to have negative here. -2.5 and 3, more positive than negative. It's positive. And then negative minus some more, it's definitely going to be negative. So that's negative over negative. This part's positive. Okay. And then here, I'll try 0. So I'm going to have positive over positive times negative, positive over negative. That's negative. And then here, I'll have all positives. Do make sure you at least check this. Sometimes you get in the habit of this is just all positives. If you have backwards subtraction here, then you can get a negative there. Like if that was 3 minus x, then you would get a negative. So just to make sure you actually at least look at that for a second. Okay. All right, and so then what do we want? We want it less than or equal to 0. So we want the negative section right here, and we want the negative section right there. So we're going to go from negative infinity to -3, and we're going to go from -2 to 3. And we always use a soft parenthesis on infinity. And then the other ones, typically when we have the or equal to, when we have the line under it, we use brackets. And so you might think that we would put brackets at all of those, But that would be incorrect. That would be wrong. We actually can't put brackets on all of those. There's a problem. Notice I left out the step for just a second of putting the open or closed circle on the critical points on that number line there. Okay, so normally when it's or equal to, we put closed circles on the number line for the critical points, because normally all the critical points are solutions to the equation. But here that's not the case. The only critical point that was a solution that was when it's equal was x equals -2. So x equals -2, that's a closed circle. That's a number that is a solution to this equation if I switched it to an equation. So equals 0 critical points, those are the ones that we always worked with before. Those are the ones where we can have a closed circle. But where did those other two critical points come from? They came from being undefined. Well, if it's undefined at positive and -3, it can't be a solution. It doesn't matter what the inequality is. It doesn't matter if it's less than, greater than, less than or equal to, greater than or equal to. It doesn't matter what the inequality is. If I'm undefined at those two numbers, they can't possibly be solutions. So I'm going to have an open circle there and an open circle there. Your undefined critical points are always going to be open circles, no matter what that inequality is. So this is a parenthesis, and that's a parenthesis, and only that one is a bracket. So watch out for that. Those undefined critical points have to always be open circles. And there's our answer. All right, so that's that one. So I've got a couple problems for you to try now. Why don't you go ahead and give these a try. So this first one here will be very similar to the one that we just did. And then I've got one where I'm asking you where it's positive, but this time I'm going to give you the graph. We looked at that in the previous lesson a little bit, looking at graph in a graphing calculator. Why don't you try it now if you don't even know what the equation was, just looking at the graph. See if you can figure those two problems out. So here are the solutions. You can check and see if you got these here. So again, make sure that you factor it. Will make your life a lot easier when you are figuring out all the positives and negatives. And then make sure you had a parenthesis on 1. Even though there was the or equal to, x equals 1 was when it was undefined. And so those critical points that were undefined have to have that parenthesis there. And then for the problem with the graph right there, positive is greater than 0. I'm going to be asking you this in the Ed puzzle in just a second, so make sure that you remember that positive is strictly greater than 0. 0 is not included. 0 is not positive or negative. And so greater than 0 positive, that's above the x-axis. So this section is positive, this section is positive, that section is negative. We've got these 2 points right here where it equals 0, 0 is the x-axis. So you didn't have to, but if you wanted to do a sign chart, the number line here would look like this. -5 and 1 are the critical points. They're open circles because it's a strict inequality. And then again, positive, we want those sections above the x-axis there.